Everybody, welcome back to a GCSE maths video. In this maths video we'll be looking at some further rules of indices, and mainly we'll be looking at what happens when we have an expression already to the power of something and that whole expression is to the power of a different number. So let's just have a look. So if we've got this little rule here, it says to raise a power of a number to a further power, multiply the indices. So let's see what's happening in this first example. So x squared to the power of 3, we're multiplying the indices. So you've got x, 2 times 3, which is x to the power of 6. Okay, what about the next one? So same thing here, it's the same layout. So you've got a to the power of 4 to the power of 2. So you're just doing a to the power of 4 times 2, which is 8. Okay, so that would differ compared to if we had something like this, a to the power of 4 times a to the power of 2. Because you've got that times and the whole thing's not raised to the power of 2, you would just add the indices. So that would be a to the power of 6. But then if you have, everything to the power, that's when you multiply those indices. Okay, let's look at the next part. So 3x squared times 4x to the power of 5. What's happening here? So whenever you have more complex multiplication like this, you want to take it step by step. So the first step is to think about these constants and multiply them first. So 3 times 4, that's going to be 12. And then deal with the x term. So what's x squared times x to the power of 5? Well, we know that we just add those powers. So it's going to be x to the 7. Okay, let's try the same logic with the next problem here. So first we want to multiply, this is part D by the way, we want to multiply the constants. So that's going to be 20. And then we want to add the power terms. So that's a to the power of 9. Okay. And now we have part E, which is a division. And it's exactly the same method, but you're just dividing this time. So we first want to deal with the constants. So, or the integers in front of the x term. So we have 12 divided by 3, that's going to be 4. And then x to the power of 5 divided by x to the power of 2. That's going to be x to the power of 5 minus 2, which is going to be 4x to the power of 3. Because whenever you have a divide, remember you subtract those indices. Okay, and then finally we have a problem where we have 3a squared all to the power of 3. So again, I want you to think about this separately, so separate it. So first of all, I want you to think about 3 to the power of 3. Because what this is basically the same as is saying 3 to the power of 3 times by a squared to the power of 3. So you want to get rid of that 3 to the power of 3 first, so that's 27. And then a squared to the power of 3, well, we know that they multiply out. So what's 2 times 3? That's going to be 6. Okay, so these are some additional rules that we need to keep in mind when dealing with indices. So let's take these and do some practice questions. So write in a simpler form, 3 squared to the power of 2. Okay, so if you remember, we multiply those out. So it's going to be 3 to the power of 2 times 2, which is going to be 3 to the power of 4. 8 squared to the power of 10. So again, we're going to multiply it out. So 8 to the power of 2 times 10 is going to be 8 to the power of 20. N to the power of 7 times 2 is going to be again multiplied out. So we're going to have n, 7 times 2 is n to the power of 14. 3 to the minus 2, all to the power of 2. That's going to be 3 to the power of minus 2 times 2, which is going to be 3 to the minus 4. Okay, so now we've got some more interesting examples where we integrate that integer at the beginning of the expression. So remember what we said, we always deal with the number part first. So 7 times 2, that's going to be 14. And then we can deal with the x term. So what's x to the power of 4 times by x? Well, that's going to be x to the power of 5 because you're just adding, remember you're just adding the integers. 2x is the same as x to the power of 1. So you're essentially doing 4 plus 1. Okay, what about 6y squared times 2? So always again deal with the number terms. So you've got 12 and this one doesn't actually have any y terms. So you're just going to have that y squared at the end. Okay, so 2p times 5p to the power of 5. So again, let's deal with the number terms first. So that's going to be 10. 2 times 5 is 10. and then we can deal with the p terms. So we know that p is to the power of 1, so what's p to the power of 1 times p to the power of 5? Well, that is going to be p to the power of 6, because you just add them. Okay, and then finally we have these other ones where we have a number term, and that is included in the power. Okay, so we want to separate it out. So 3a squared all to the power of 3 is the same as saying 3 to the power of 3 times by a squared to the power of 3. We've just kind of separated out that expression. And so 3 to the power of 3, that is 27, times by a to the 2 times 3. So that's going to be 27a to the power of 6. Let's try the same example with different numbers. So 4y to the power of 3 all to the power of 2. So that is the same as writing 4 to the power of 2 times y to the power of 3 to the power of 2. Okay? So what's 4 squared? Well, that's going to be 16. And then what is y to the power of 3 all to the power of 2? Well, that's going to be y to the power of 3 times 2. So overall, we've got 16y to the power of 6. Okay, so this is basically all you need to know for the rules of indices. Of course, you have the aspects of division, but that is exactly the same. Instead of, multiplying, you're dividing. Instead of adding powers, you're subtracting powers.